Unit 6, Lesson 4, Using Trig to Find Missing Angles. So think about how you would solve the following equations. 2x is equal to 14. We're solving for x. It's 2 times x, so we're going to divide out the 2 and get x is equal to 7. X squared is equal to 9. We need to reverse the process of squaring a number, so we're going to take the square root of both sides. We also are going to have a positive and negative result. So x is equal to plus or minus 3. How do you think we would solve sine of x is equal to 1/2? So we need to solve for the variable x, and in both cases up here we used inverse operations, meaning we reversed the operation. We're going to do the same thing in trigonometry. So how can we undo everything? How can we get x by itself? So if you take a look at this diagram here, it's showing a very old TI calculator, which is not what we use. But the way to do the inverse operation in trigonometry is we arc sine both sides. So what you do to one side, you do to the other. Just like what we do in solving equations. Okay, so just follow along here. So if we arc sine both sides, that cancels out this sine, and we have the arc sine of 1/2. That is the same thing as sine inverse of 1/2 is equal to x. Anytime you're looking for the angle measured, the variable x is the angle. We haven't done that before. This is the first time. In our calculators, instead of using arc sine, we're going to use sine inverse. So please look at your calculator, hit the trig button, which is to the left of 7, and select sine inverse, which is below sine. In the parentheses, put 1/2, and you're going to get x is equal to, you're going to get 30, but we're going to write down x is equal to 30. So that means the value of x, the variable, is 30 degrees. Okay, and as you can see, if you read down here, that is the same thing as arc sine of 1/2. So in this case, we want to find the angle measure, and we're going to use sine inverse, same thing as arc sine. Oh, we may not be using sine inverse. It all depends on the values that they give us. We may be using cosine inverse or tangent inverse. We have to figure that out. And the way in which we figure that out is we're going to revert back to SOHCAHTOA. We're going to figure out what values they give us, and we're going to set it up and then go from there. So we want to find the angle measure from the boy to the top of the tree. So that's this angle here. You can put an x there, you can put theta. I prefer theta, the Greek variable. Round your answer to the nearest hundredths. So here's my right angle. Across from it we know is the hypotenuse, so we're not doing anything with the hypotenuse. And if we go back to SOHCAHTOA, the two functions that use hypotenuse are sine and cosine, so that rules those two out. The only thing that we have left is the opposite and the adjacent, which deals with tangent. So tangent of the angle theta is equal to 28, the opposite side, over the adjacent 40. So because I'm looking for the angle, which is to the left of the equal sign, I'm going to use tangent inverse. That's how we know the difference. Plug that into our calculator, 28 over 40 in the parentheses, and we're going to get the angle. So go ahead and try that in your calculator now. Trig button on your calculator, which is to the left of 7. Select tangent inverse. Insert 28 over 40. Control Enter. Rounded to the hundredths spot, you should get 34.99 degrees. Example 2, find the measure of the labeled angles to the nearest degree. So we have angle A here. I don't have the opposite. I am given the hypotenuse, and I am given the adjacent. So that means I'm using the cosine function. So cosine of A is equal to the adjacent 13 over hypotenuse of 20. We're using the cosine inverse. Plug that into your calculator. Now in this case you're asked to round to the nearest degree, so you should have 49 degrees as your approximation. And for the other right triangle here, I have the hypotenuse and I have the opposite. So the function that deals with opposite and the hypotenuse is the sine function. So sine of B is equal to the opposite 40 over the hypotenuse of 42. I'm looking for the angle measure B, so that means I'm using the inverse function for sine. Plug that into your calculator, and we're going to get an approximation rounded to the nearest degree. Go ahead and do that now. Yes, rounded to the nearest degree, you get 72 degrees. Now an application to real life in example 4 here. A 16-foot ladder leans against a wall. The foot of the ladder is 7 feet from the wall. Find the vertical distance from the ground to the point where the top of the ladder touches the wall. Round your answer to the nearest tenth. The first thing that I would do is draw a picture. So there's my wall. The 16-foot ladder is lying against it. The foot of the ladder is 7 feet from the wall. So find the vertical distance from the ground to the point where the top of the ladder touches the wall. So that's x. Since we're looking for the third missing side of a right triangle, you can use Pythagorean's theorem for this. So we can have x squared plus 7 squares equal to the hypotenuse square. Go ahead and solve for x. So if you hit Control Divide, when you take the square root of 207, you're going to get x is approximately equal to 14.4 when rounding to the 10th spot. Now we want to know what the angle measure is for that's formed by the ladder and the ground. So that's this right here. And we're asked to round the answer to the nearest degree. So there's a variety of trig functions you can use. We'll go back to SOHCAHTOA, pick whichever one that you feel most comfortable with. You do have that third missing side now that you found it. I'm just going to go with the cosine function. Cosine of theta is equal to the adjacent side 7 over the hypotenuse of 16. I'm going to use its inverse function, which is the arc sine, and to the nearest degree, go ahead and find out what that value is. And when you hit Control Enter, you're going to get 64 degrees. Okay, now for some exercises. We want to find the measure of angle C to the nearest degree. So again, go back to SOHCAHTOA, figure out which one of those trig functions you have. It's all based on the information that's given. We're looking for C. We've got to figure out what the function is, and that's set equal to the ratio of the sides the opposite and the adjacent. So 14 over 29, that means we're using tangent. Since we're looking for the angle measure, we always use the inverse function. Go ahead and plug that into your calculator, hit Control Enter, and tell me what you get. Yes, you bet, it's 26 degrees. Okay, so find the measure of D to the nearest degree. Why don't you go ahead and try to set this up? Don't forget to write down SOHCAHTOA. Which one of these trig functions do you want to use in order to find the measure of angle D? You can use any one of those three. It's entirely up to you because they've given you all values for the sides of the right triangle. I'm going to write out all three. You pick whichever works best for you. So sine of D is equal to the opposite side of 68 over the hypotenuse of 85. Cosine of D is equal to its adjacent side of 51 over the hypotenuse of 85. And tangent of D is equal to the opposite 68 over the hypotenuse of 51. So because I'm looking for the angle measure, I want to use its inverse function. No matter what, you're going to get the answer. They will be the same. So go ahead and pick your poison and get the answer. It doesn't matter which one you use, you're going to get 53 degrees. is equal to the angle for D. A roller coaster travels 80 feet of track from the loading zone before reaching its peak. The horizontal distance between the loading zone and the base of the peak is 50 feet. At what angle to the nearest tenth of a degree is the roller coaster rising? So make sure we round correctly to the nearest tenth of a degree, and we want to know what the angle is that the roller coaster is rising. So this is what our value for x is, or you can label it as theta. So based on the information that's given, we can't use any trig function because not all three sides of the right triangle are given. So we do have the adjacent side and the hypotenuse that's given. That means we're using cosine. So cosine of x degrees is equal to adjacent of 50 over hypotenuse of 80. Since we're looking for the angle measure, we must use its inverse function, plug in the values, and get what our degree measure is to the nearest tenth of degree. Go ahead and do that now. And it's 32.0 rounded to the tenth spot. So this concludes this lesson. At this time, take the opportunity to complete your homework and hand it in for a grade.